This is Computers as Components, Chapter 2, C64x Instruction Set. The C64x is a family of high-performance DSPs that use VLIW technology. They can execute up to 8 instructions per cycle. The data path is divided into 2 units called A and B. It provides floating point as well as integer arithmetic. It's a Harvard architecture. And instructions are grouped into fetch packets for fetching and execute packets for execution. Here's a block diagram of the C64x. You can see the 2 data paths here, A and B. Each data path has its own register file. Okay. Then it has a large execution unit. It has a data RAM and program RAM that are separate. It has a set of control registers that control all the execution on all the data paths. Now, why have 2 separate data paths rather than just one? It's because the larger the data path, the larger the register file, the slower the register file. So by breaking the register file into 2 pieces, we can make the data paths in combination with the register files run faster. But that means that if you want to take data from, say, register file A and use it in data path B, you have to explicitly copy that data from A to B. Okay, and that takes a cycle. But within a data path, any instruction executing on A, for example, can use all the data in register file A. Any instruction executing on B can use all of the data in register file B. So in the two data paths, there are units called L1 and L2 that perform 32 or 40-bit arithmetic, 32-bit logical, data packing and unpacking instructions. There are 2 units called S1 and S2 that perform 32-bit arithmetic, shifts and bit field ops, 32-bit logical ops, branches, and so forth. There are units called M1 and M2 that perform multiplications, bit interleaving rotation, Galois field operations, and so forth. And D1 and D2 perform address calculations, load stores, and so forth. So there's one set of these operations for the A data path, and then the B data path has its own set of function units. Now, there are a lot of constraints on what can be done simultaneously, and the compiler or the assembly language programmer has to make sure that this code does not violate these constraints. Okay? So we can't run 2 instructions that require the same function unit at the same time. So, for example, if 2 instructions both need S1, they have to run separately. Most of the write combinations between M1 and M2 are legal. Most cases of reading multiple values from the opposite register file are illegal. A delay cycle is added for a register read after update from the cross path. You can't execute 2 load stores using destination source from the same register file. You can read at most 4 locations from a register at once, and you can't write to a register twice in the same cycle. The architecture provides several other features. It provides atomic operations for semaphores, some circular addressing modes, delay slot operation for performance optimization, and the interrupts are mediated by 2 registers, IFR and IER.